looking at arithmetic sequences. To start with, pull this up, maybe not a little bit. A sequence is just an order list of numbers. Each number is called a term. So you have a bunch of numbers in a row, that's just called a sequence. An arithmetic sequence is an order list of numbers in which the same number is being added or subtracted between each term. So that's important. Arithmetic is when you add or subtract the same term. The same number is being added or subtracted. Okay? Common difference is what that is called. So the common difference is the number that is being added or subtracted. Each time. So in this case we have 5, 10, 15, 20. The common difference here would be 5. That's the number that's being added or subtracted. And common difference is represented by the letter D. Okay? So finding the next term in a sequence, we're going to be looking at patterns and seeing if we can figure out what will come next. So write the next 3 terms in the arithmetic sequence. So to figure out, identify the common difference, what's happening between the numbers, we typically want to, we know that it's being added or subtracted by something, so what I want you to do is take the second term minus the first term. So in this would be the first term, this is your second term that you see. So if you take negative 14 minus negative 7. Negative 14 minus negative 7 equals negative 7. So the difference between these two is negative 7. So if you have negative 14 minus 7, you're going to go to negative 21. So the difference between all these are going down by 7. So this is just a helpful way. How do I figure out what it's going down by? You subtract the second one minus the first one to figure out the difference between. So what is the difference? That should be down here. The difference equals negative 7. Add the common difference to the sequence as many times as asked for. This one said the next 3 terms. So if you start at negative 28 and you add negative 7, you would get negative 35. So that's considered the next term in the sequence. Okay, and it wants us to find the next 3 terms. So I'm going to draw 3 blanks. So now you'll take negative 35 and minus 7, or add negative 7. That gives us negative 42. Again, subtract 7 more. That gives us negative 49. So the next 3 terms they were looking for are negative 35, negative 42, and negative 49. Alright, now it's your turn to try it. Here's 3 terms in a sequence. See if you can figure out what's the difference between them, and then tell me what are the next 3 terms. So I'd pause the video, try the math, and then turn the video back on to check your work. So if I take the second term minus the first term, that would be 0 minus negative 12. Comes out to, cross the line, change the sign, 12. The difference between each of these, it is going up plus 12. So if you take 24 and you add 12 to it, the next number would be 36. Then we add 12 more, that's 48, plus 12 more, that would be 60. This would be the next 3 terms, looking for patterns. The reason I use this little helpful second term minus first term is because, like on decimals, sometimes our fractions, we don't necessarily just recognize right away what the difference is. So let's do it. The second minus the first, that would be 0.6 minus 0.2. This one has a difference of going up by 0.4. So we're going to take 1.4 and we're going to add 0.4 to it. So that would be 1.8. Now plus 0.4, that gives us 2.2. Then add 0.4. So that's finding the next three terms in a sequence. These are all arithmetic, so they're always adding the same number, even if it happens to be a negative or adding a positive. Alright, now we have two different types of formulas here. We have one that's called the recursive and one that's called the explicit. The recursive formula is written in two parts. N represents the number of the terms, and D represents the common difference, which we already talked about. Common difference is what's happening between the numbers. So it has two parts. You have to tell me what is the first term in the sequence. That's the little one. Little one means first term. And then this is like the formula. So in this problem, the first term here, this is the first one, that would be 12. This is kind of, it didn't somehow subscript, so I'm going to cross that off. And we're just going to write it below it. It should look like the A, I don't know if you can tell it by the formula, but the N minus 1 should be what's called a subscript. It should be little letters. And then you do plus. Okay, we have to figure out what is the difference. So again, second minus the first. You take 7 minus 12. This one is going negative 5. So it's going down 5. So I would put, that's called your common difference. That's what it was changing by. So you can put plus negative 5, or you can just write minus 5. So you have to put A1 for the first term. Then you have to do the actual equation. So let's look at the next one. First term for this one is 2. Okay. Again, these should be little subscripts like that. I don't know why they aren't. But then if you take 8 minus 2's, you get 6. So this one is adding 6 each time. So that's what it would look like. You have, this is the formula. The only thing we replace in this formula is right here where it says plus D. That's the common difference. You just put whatever number is being added or subtracted by, plus that number. So this was plus 6. This one was plus negative 5 because it was going down by 5. Okay? Alright. Let's look at the next kind. The next one is called explicit formula. Explicit formula is kind of more, last chapter we learned about linear. Linear is when something's being added that has a constant rate, a constant change. Well, arithmetic always has a constant change. Here's the explicit function, and it tells us, my highlighter, the explicit formula is this. It only has one part to it, where it says the A1 represents the first term, so that's still the same. N is the number of terms you are solving for, and D is the common difference. Okay, so I'm going to put a little arrow here. We're going to say first term, common difference. So this one says write the explicit equation for the nth term of the arithmetic sequence, and it gives us a list of numbers. So if you wrote the formula for this, the formula is A sub n, that's what the little subscript means, A1 plus n minus 1 times D. Okay, now it says plug in A1, D, and n. Okay, well, let's look at our numbers here. The A1 is 14. The difference between them, let's do the work over here. 11 minus 14 equals negative 3, so it's going down by 3 each time. So our A1 was 14. And then our difference was negative 3. The reason I didn't plug in the number yet is because at this point we are really wanting to see if you can simplify the expression, not just solve the equation. So if you were going to do that, we would want to get rid of parentheses. So we distribute with parentheses. And then you would combine like terms. So 14 plus 3 is going to give us 17. So this is like the equation we were looking for. It should look very similar to like y equals mx plus b. You have, if this was the y, this could be like negative 3x plus 17. So this is a linear equations because they are adding the same number each time. Okay? This is just called the explicit formula. So the last thing we need to do is find the 50th term. So a 50 means let n equal 50. So negative 3 times 50 plus 17. We did that in function notation in like day 3 of last chapter where they give us a number like 50 and you had to plug it in to find the answer. So that's negative 150 plus 17 equals negative 133. So that's considered the 50th term. If you want to write that, it would look like a with a little 50 equals negative 133. So that's saying the 50th term in the sequence would be negative 133. So instead of taking this and subtracting 3, subtracting 3, subtracting 3, all the way till you get to the 50th term, we can use this formula now to find that term. If you're only finding like the 6th term or something, like yeah, maybe just subtracting 3 a couple more times would be fine. But when you're trying to find terms that are a long ways from where you started, it's better to use an equation. So write the explicit equation for each arithmetic sequence. Find the 15th term. Alright, so the equation is going to look like, you need to know the difference. So 16 minus 8 equals 8. So the common difference for this one is 8. It's adding 8 each time. Okay, so A1, here's my formula. A1 is 8 plus n minus 1 times 8. And they wrote f of n instead of like a of n. It's okay. We're going to distribute to get rid of our parentheses. Then we're going to combine like terms. I'm just going to do that work down below. So we'll just say function n is 8n. You do 8 minus 8, those it's like you can put plus 0, but you don't need to. Now it says we want to find the 10th term. So the n is the term. So 8 times 10 equals 80. So this line is what I would call my equation. And then you plug in whatever number they give us. So f of 10 equals 80. Okay, if you want to pause the video and try the next one on your own, go for it. So first term, second term, subtract the 2. So 0 minus 1 equals negative 1. The common difference here, it's going down 1 each time. The equation is, we start with A1, so our A1 was 1, plus, parentheses, n minus 1, and then d. Our difference was negative 1. We distribute, so you get negative 1n plus 1. So my equation would be negative 1n plus 2, because 1 plus 1 is 2. So this is the equation I would look for. And then this one again says we want to find the 10th term. So where you see the n, this is n equals 10. So negative 1 times 10 plus 2. So the 10th term in the sequence, that gives me negative 10 plus 2 would be negative 8. So different ways to write it. This is kind of function notation way we wrote it before. This is kind of what the explicit formula way, but you're writing the equation and simplifying with explicit, and then you're plugging in whatever number they give you. The next ones, they give you a table version of this, instead of giving you just the numbers in the sequence. But remember, on all these I've been writing a 1 and a 2 above it for the first term, the second term. The same idea here, they just give you that top row of first term, second term, third term. So with that being said, we're just looking at the bottom number. We're looking at the actual function. We want to find the difference between the two. What's happening here? Again, with decimals, sometimes it's hard to tell, especially with negatives. So you take negative 0.8 minus negative 1.3. Let's see. Cross the line, change the sign. So we get a difference of 0.5. So my difference is 0.5. We know the first term is negative 1.3. I'm going to do the explicit one first, I think, because that's the one we just practiced on this page. So it says AN equals the first term, negative 1.3, plus n minus 1 times 0.5. Once I plug it in, you distribute. And then I'm going to combine those like terms, so I'd have 0.5n minus 1.8. So that is your explicit. Okay. The recursive is the one we did on the front side, or the first page of this. So the recursive one is kind of where it has two parts. You have the A1 term, so we'll write A1 equals negative 1.3. And then you have the second part where it says A sub n equals A sub n minus 1, and then plus whatever the difference is. And our difference for this one was 0.5. So the recursive has the two-part, the explicit has the one where you get to plug it in and then simplify it. Okay. It's the difference between the two. So we got to figure out what is our difference. What's happening between each of these? Definitely the numbers are going up. So what are they going up by? So you take 13 minus 2, and that would be 11. So it's adding 11 each time in the sequence. So the first term, A1, remember this is first, second, third. Our first term was 2. And then you do A with a little n minus 1, and then plus whatever the difference is. This difference we said was 11. That's what the recursive looks like. Instead of writing on two lines like I did here, I just put a semicolon between the two, just so I can fit it all in one line. Sometimes I do it both ways. And the last one, recursive formula, you have A sub n equals A1, which is 2 plus n minus 1 times the difference of 11. Distribute. Combine like terms. So that is our explicit equation. If you want to see if your explicit equation is correct, all you do is you take your formula and you plug in like 1. If you plug a 1 in, do we get the answer of 2? So I'll show you on a calculator versus writing that down. So we said it's 11n minus 9. So get the glare off there. That helps. So 11 times 1 minus 9 equals 2. And you can see the first term came out to 2. So let's plug in a 2. 11 times 2 minus 9. Second term is 13. So this formula you can always check by plugging the number 1 in, get this answer. Plug the number 2 in, get that answer. If you're not getting these answers, when you plug in a 1 or a 2, then your formula isn't right. Let's go back over here. 0.5 in, 0.5 times 1, okay? 0.5 times 1 minus 1.8. See that, but 0.5 times 1 minus 1.8, that was our formula, and I got negative 1.3. You can look at the table here, it's negative 1.3. So I know that my formula that we came up with was correct. So arithmetic is adding the same number every time. That number you're adding is called the common difference. We learned two types of formulas today. One's recursive, which is the long one. Explicit is the shorter one, but you have to distribute and simplify.